Good afternoon. My name is Danielle Atanasio, and I work in the SUNY Plattsburgh admissions office. We're really happy to have you here for our virtual open house, and you are here in an academic breakout session to talk about computer science and physics. We have two panelists, representing both of those departments, obviously, and I'll give them a chance to introduce themselves in a moment. But what's going to happen here today is they're going to give you a short presentation about their departments. And then at the end, we're going to have time for some questions and answers. So you'll be able to submit your questions in the chat bar, and we'll answer them live for you as they come in. So I will turn it over to our panelists to introduce themselves.
Hi, I'm Dr. Hart. I'm representing the computer science department. I'm a professor and chair in the department. And I'm very happy to speak to you in a second about our courses and majors.
And I'm Dr. Michael Walters. I'm in the chair of the physics department, and between the two of us, we share the robotics. So we hope you enjoy our presentation.
So as I mentioned, I'm Dr. Albert Hart, and I'm representing the computer science department. In the department, we have 4 different majors that are available: computer science, computer security, information technology, and robotics. The computer science major is kind of a generalist degree. Computer security, as the name implies, looks at different aspects related to keeping systems safe. Information technology is kind of about how to get all the systems working to help the users out and to make things work correctly. And the robotics program is a new program at the partnership with the physics department about how to do how to make small off-the-shelf components, into your minions in some sense. So the computer science major is our largest major in terms of number of students because it's the kind of the traditional degree, and probably about half of our students are in that major. The major itself isn't real large because we were just focusing on the core so that you can partner it with other majors or minors if you're interested in that. And we've had a number of students over the years like do an art major or English major or biology major or some other major and combine it with computer science. In the technical field also has a very strong growth potential. So from the Bureau of Labor Statistics, their estimate over the 10-year period is that there'd be over 20% growth in just software developer types of jobs. And that's probably the biggest job category from the computer science degree. There's other types of things that you could do, like when you hear about data science and stuff like that, that's another type of job that'd be computer science based. The computer security degree is a little bit larger. It has a core of courses, and it kind of combines both computer science and information technology for the core. And then because there's lots of different ways that you can go, there's also different aspects of security. We ask students to choose a concentration of about 9 to 12 credits to kind of give them a little more depth and a little more focus in terms of what they're interested in for security. The computer security in terms of jobs, probably one of the biggest jobs is information security analyst. And that's where students or where a person would work in a security operations center to analyze, what types of risks are involved with, using this type of software or doing that sort of process, or how we need to keep that data safe. So that's a big growth area as everyone tries to do a better job in that. Network engineer is someone who kind of designs technical controls and measures to actually keep things safe, and there's jobs along those sorts. And a lot of students are interested when they come in being penetration testers, kind of the white hat hackers. So that's another type of job. There's not probably as in terms of raw numbers, there's probably not as many jobs for that, but students are excited about that one. And then graduate school is another option for all of our majors. The information technology major, the idea in information technology is not that you're selecting computer science, you're doing more software development. So you're creating new solutions for things. Whereas in information technology, it's more about applying and kind of hooking things up and getting things to work correctly. So there's a lot of configuration, there's a lot of tweaking that needs to occur to make things work out in practice. And so the information technology is about kind of getting the background and experience in order to do those sorts of things. One of the main jobs associated with information technology is system administrators. So the people who, make sure that the machines are safe and secure and running properly. Other types of jobs associated with that might be a network administrator, who's doing the same sort of thing for the whole organization. Help desk technician is another kind of common job with that. Systems analyst is a person who talks to users to find out what their needs are and then kind of translates it to software developers so that there's a clear communication between what users' needs are and what the software is being developed. And then IT people sometimes have to do kind of a small amounts of software development here and there. Robotics major, I'm going to let Dr. Walters primarily talk about, but one thing I'll say is that, it has kind of two tracks. So we have a core of material, and then there's a programming track, which is more computer science courses, and then a hardware track, which is more physics courses. But it's a great program, and it's something that we're excited to be a part of. For experiential opportunities, we think that it's very important for students to get hands-on experience with software and systems. You can read about things, but until you start doing it, it doesn't really coalesce and doesn't really build the skills that you need until you're doing this stuff. And so we try to provide opportunities for students to get that hands-on experience. On an individual basis, a lot of students do internships, probably at least say 10% of our students do internships. A lot of times those are over the summer or the winter, and they're in whatever area the students live. And then also on campus, there are a few internships, and there's also faculty do research. And so students sometimes participate in that research, and other times students have their own interests, their own projects that they want to take on, and faculty are happy to kind of help them out and to sponsor them in those investigations on their own. In kind of a more formal setting for groups, we have experiential opportunities. One neat one that we just started this past year is called the Tech Startup Courses. And what it is an opportunity for students to work on the same project for multiple semesters. And it's attempting to try to give as real life of an experience to developing software as possible. One of the big hurdles in kind of a traditional project course, which we do offer to many students take, is that by the time you get up to speed, by the time you really start getting into your project, the semester is over. And so then there's things like maintenance and just all sorts of other things that don't really come up in a one semester project. And so the tech startup courses are an attempt to give students a more real life experience. And they're also set up in a way to let students work and improve their leadership skills and kind of the team communication skills, because those are very important in the real world. Another big kind of formal opportunity is through our Center for Cybersecurity and Technology. A lot of our computer security students and IT and computer science to some extent participate in the Cybersecurity Center, and through that they get hands-on experience with cybersecurity tools in an environment where they're not going to cause havoc or damage across the campus. The kind of extracurricularly, there's a number of student groups on campus. And so like we have a software engineering club who's been pretty active, and they have speakers and they talk about career development, and they do different activities and stuff. And then we have a coding hub group, and the coding hub group are just a bunch of students who got together because they just wanted to work on improving their programming skills. And so they get together and they focus on, you know, kind of software development in an extracurricular setting. And so this is all student driven. And they've done some interesting things where they've done projects for like the student association, like they wrote an app to track where the student association bus was, so that people could know how long they have to you know, get it someplace to catch it. So they've been very active in doing stuff. And you know, last spring, spring 2019, we had a hackathon on campus. And so, you know, that's something that was a lot of fun, and the students, it was all student organized and done. For students coming onto campus in the spring, you know, if you don't have any background, that's fine. We have a couple courses that you would take. One is pre-calc. Pre-calc is a prerequisite for all of our technical classes. And the other is CSC 121, Introduction to Computing in the Web. And that's just kind of a technical overview of courses, of computer science for anybody. So there's no technical expectations coming into the course. It's just to show you kind of an idea of how things are actually working and to give some context for the rest of your career. After you've had pre-calc, or if you've already had pre-calc, then you can take the Discrete Math course and the Introduction to Programming course. And those are kind of gateway courses to the rest of our technical courses. And so those would be the next steps in the system. And that, as you can see, 221 is kind of in the middle of the top there. After you take that, there's lots of options you have, but until you've taken that, there's not so much for options. So anyways, that's kind of a quick overview of our department and majors, and I'll let Dr. Walters speak about the physics programs.
Thank you, Dr. Hart. And being a physicist, we have to start off with an obligatory Muppet slide, because when we get our PhD, we have to sign a form saying that whenever we give a presentation, there will be an obligatory Muppet slide. So this is the Muppet slide of choice for today. We have a lot of different flavors for our major here at SUNY Plattsburgh. The BS in physics is the traditional degree you would think of if you're going to go to school for physics and then go on to graduate school and work towards your PhD or a master's. It studies the traditional things like quantum mechanics and electricity and magnetism and thermodynamics. The BA, you still can go to graduate school, but it's sort of shaded now. I want to come get a bachelor's in physics and then go on maybe for a master's or a PhD in engineering. I want to do it in that aspect. You can come here and do that as well. What we do is we give you enough flavor of those engineering courses such that you get enough of a background that when you go to graduate school, you don't have to take many preparatory courses to follow that. But as well, you can go into industry. I went into industry as a physics major and played as an engineer for 10 years. So you can do something with your degree, with a BA degree, in terms of just getting a job straight out of college with it. Similar to that is our 3+2 engineering program. The 3+2 engineering program is neat. You come here for 3 years, and basically during those 3 years, you get your general education courses out of the way, as well as work on your physics degree. So you take all your physics courses while you're here. The neat thing about taking the physics courses while you're here is we also allow you to sample the introductory engineering courses that you'll take when you go someplace else. So let's say you're an electrical engineering student. You want to go into electrical engineering. You would take our Electronics for Scientists course and Advanced Digital Design course while you were here. Or if you were going to be a mechanical or civil engineer, you might take Statics and Dynamics and Strength of Materials here. as part of your physics degree. This is sort of in the same lines as our physics BA. After 3 years here, assuming you've gotten good grades, you then transfer, you apply for transfer to another school. And I'll talk more about the schools in a minute where we sent people, but you go to that school and basically you concentrate just in the engineering aspect that you're looking for 2 years. And once you're done with those 2 years, you transfer back the credits that are needed. So you graduate from there with your BS in engineering, you transfer back the credits you need to finish up your BA here. So basically in 5 years, you get 2 degrees, a bachelor's of arts in physics and a bachelor's of science in the engineering discipline from the institution that you transferred to. Our robotics BS, which I'll spend a whole slide on in a little bit, is great because when we were building this program, we brought in people that to just check out if what we say we were going to do, could you get a job in industry? Oh, my lights just turned back on. To get a job in industry, or could you go to graduate school? And our reviewers unanimously said that you could be able to do both with our program. And so that's great for our students. It deals in small scale robotics. And the reason for that focus is because with today's technology, you can do everything in robotics with small scale robotics, at least to learn the fundamentals. Used to be that you had to have a $1 million, $10 million lab to do robotics. That's not the case anymore. But that's also why you don't see, schools are still trying to transition. That's why you don't see a lot of schools have a robotics program, because they're still in that mindset of it's got to be a $10 million lab, and you only let graduate students play in that. You don't let undergraduates play. So we have one of the few programs in the country that allows you to specialize in robotics in undergraduate. And lastly, I do want to spend a couple seconds. We have a physics adolescent education. Basically, we call it the BA MST program. What happens is you're working on a bachelor's of arts in physics. And then in your senior year, you could start taking master's courses in education. And what happens is basically it condenses it down such that you only spend 1 year in graduate school to get your MST. So you get basically both degrees after 5 years. And it prepares you to go teach high school physics. The program has 2 awesome things about it. One is the idea of taking courses, graduate courses at undergraduate prices. That's always a bargain, and that's an important thing. The other thing, which I think is more important, is it gets you in the classroom earlier. Usually in your sophomore or junior year, they have this experience where you go into a classroom. You're not teaching. Don't worry that you have to go in and start teaching right away. But what happens is you get to see what's basically behind the curtain. You know what your high school teacher did when they were presenting to you. You don't know all the stuff they had to do in the background. And so this is now an opportunity for you to see what was behind the curtain and really know if this is something you want to pursue. It's very important to do this early, and we're going to talk more about experiential learning throughout this thing. It's important to experience stuff early because so my wife decided to go get her master's in education, and towards the end of the program was the first time she got to be in a classroom. She found out she hated it. We have a master's degree that she doesn't use because it just wasn't her. You could prevent that by coming here and trying it out early, which is great because it gives you that experience. Now, for the robotics degree, this is awesome. This is definitely a collaboration between physics and computer science. Without either half, we couldn't really pull this off. And so it is such a neat course. We separated out into a hardware and a software section, and it's a concentration. And basically what it says is if you take one of these 2 concentrations, let's say you take hardware, you're going to take 5 or software, you're going to take 5 courses in that concentration. But because we want you to be seasoned, well-versed, we're going to make you take 2 courses from the other side. So you're going to take 2 hardware courses if you're more into the programming side, or you're going to take 2 programming courses if you're more into the hardware side. Now, that's not to say that you're not going to get this blending throughout the core courses. The core courses, we constantly mix these 2 things together. But the biggest thing I love about this program is the 4 courses, 4 experiential courses you get to go through your 4 years at college. The first one is a physical computing course, in which case you start working with one of these. This is an Arduino. It's a microcontroller. It's not really a computer, it's a microcontroller, and it can go ahead and turn on LEDs and basically run motors. What I love about these things, they're pretty bulletproof. Once you get it programmed, it works pretty much all the time. When you get to the second year, you start playing with more advanced hardware. Meet KIF. This is KIF. This is a robot that I've designed for teaching. This is their textbook. So when you take Introduction to Robotics with me in your sophomore year, you'll be working on a KIF. I keep changing his design, so don't memorize it. This is probably going to change by the time you get here. But what's great about KIF is it takes everything we're learning in the classroom and makes you do it with a robot. So it's not theoretical, it is practical. And that's great because I've had students who thought they were going to be robotics majors. They hit that first class where they're dealing with KIF, and they come to me at the end and say, thank you, Dr. Walters, but no, thank you. I don't want to do that ever again. And that's fine because that's what's important. Figure out what you like, what you're passionate about, and do it. Then the third year, this is a great course. It's Intermediate Robotics Lab. And what happens is you work in groups on difficult projects that have, you can't Google the answers to these projects. They don't exist. I check because I want to make sure that's the case. Like this semester, one of my groups is doing a project where they have a map that I created for them with different shapes and colors and lines drawn on it. And they have to take a picture of it with the robot, let the robot determine the best path between 2 points, excluding certain points. If the colors aren't in the beginning and the end, they have to exclude those colors. So therefore, roads that could possibly be the better roads, the faster roads, they have to exclude. And they still have to chart the best path between point A and point B, and then make the robot drive it. So basically, it's autonomous cars without the cars. It's a lot easier to drive your robot around. And I wasn't volunteering my Prius to be the robot. So we're doing that. And there's other projects along those lines. Finally, and most important to me, the senior project. This is one where you will work with your advisor and determine what the project is that you are most passionate about and what are you going to do. So we have had 2 majors get through and graduate recently. They're our first 2. And to give you an idea of their senior project, one was trying to figure out when dogs were in a picture. So they were just trying to identify dogs and program it from scratch. This is what they were trying to do, some deep learning. The other student was very much more hardware centric, and he built this interface between a robotic arm and his arm. And what made it interesting was he tried different biometric sensors that were tapping into his arm to look at like how much he constricted a muscle or how fast he moved his hand to control his robotic arm to be able to pick up a pen and try to write his name. Now, he didn't write his name, but he did manage to pick up the pen and move it around so he could make some marks on the paper. So that's great. So this is what they're passionate to do. And so you have something when you graduate here that you can go to an employer and say, look at what I did. This is what I did. These are the problems I had. This is how I solved them. These are problems that I couldn't solve. And show the employer how you think. And that's great in a job interview. They love the fact that you've had this experience, because usually in industry, when they're going to give you a problem, it hasn't been solved. Because if they could, they just Google it and order the piece. Here it is. Figure this out, and you will have that experience. Now, going back to the 3+2 program, we have placed students in many schools. So you see a listing of schools here. I'll just give you a couple oddball ones that we've also done. You don't have to stay in the Northeast. So I've had a student went to the University of Arizona. I've had a student go to University of Virginia, West Virginia State, because it was the mining school at West Virginia State. That was the type of engineering they wanted to be, was a mining engineer. They just graduated recently. And so the programs are vast. We can find a way to get you an exposure to your desired engineering field before you actually go to engineering school. And once again, that's important. See, do you like it? So like I said, for electrical, you have the electronics for scientists and digital. It's neat. It really opens things up. So I really like our 3+2 program. And some people start here with a 3+2 and decide to stay. And then they go on and get their master's degrees in engineering. We've had a lot of people do that. And this still sets you up really well for that. Our facilities, for such a small place, we have lots of facilities. We have labs. I point out 2 of them in this particular. We have a robotics and electronics lab that I oversee. We have lots of stuff that you could work with. So as you're developing your projects, even projects aside from your senior project, we have some of that hardware here to deal with. We have the North Country Planetarium. This is a great resource. There are a lot of planetariums throughout the SUNY system. Ours is very active, and the most important thing, it is student run. We have a director who her job is to empower students to develop presentations and to present through the planetarium. And I'll talk a little bit more about that in a couple of slides. That's a really great opportunity. Our students here do research. Now, when we do research, we have, especially on the physics side, I'll talk about the physics side first. We have a professor we just hired, Dr. Adhikari, who does research into the Big Bang and looking at the background cosmic radiation and trying to trace that back to the beginnings of the universe. We have Dr. Podolak, who's right there in the picture there. He was doing research in magnetics and looking at new ways of developing novel magnetic materials for like hard drives and future storage of information. And then you have me, who is a jack of all trades and master of none. Basically, if you have an idea that you want to do, you bring it to me and we figure out how to have you get the experience. Just to give you some weird ideas that I've done. Now they're weird just because it seems odd that physics were doing this, but it is. We looked at using Jello to make lenses for like optics. We also use that same Jello to try to protect people's brains from concussions by looking at how it smushes versus when you get hit in the head. I've done windmill blade design. We've looked at automation for making hurdles go up and down, so this way resets were faster for track and field. You come up with an idea, we will try to figure out a way for it to be a research project or find something similar that you can do. We also have, this is 100% student driven, a physics engineering club. And the great thing about this is a way for you to get around your peers, to network with your peers, and do really neat stuff that you don't normally think of. All these projects I'm about to talk about were students saying, I want to go do X. So the first one in the upper left, we built a trebuchet to throw pumpkins. It was great. So a student came in, I want to throw pumpkins using medieval equipment. Sure, let's go do that. And so we did. We actually won a couple. We won a year. We had a couple first, seconds, and thirds in our pumpkin chucking. We've done stuff with drones. So we have this picture there. That's our 6-foot carbon fiber drone. It's crazy to watch that thing fly through the air. We also have built an electric car that's still in the process of being built because the student who wanted it built up to that point and then graduated. How dare you? And so I still have a car that I still need finished. But the great thing about it is, once again, get your hands on. You can work with tools and great ideas and do fun stuff that way. Lastly, this is my baby. This is Rover. We call them Red Deck Rover because, as you can see, it's made out of plywood, 3D printed parts, PVC tubes. What we were challenged to was NASA put out a competition that we were going into a football field and had to find a purple rock, and it was a pretty substantial purple rock, and a piece of PVC pipe. But once again, there's nothing, you can't go on the internet and go find, here's the plans for building a rover for yourself. It really doesn't exist too well. So we did that. We went ahead and designed this robot. And what was great is it was 100% student designed, 100%. I did the sourcing, I helped with programming, but they really designed the robot from scratch, and we took it out for competition. And the great thing was we almost was able to do it, but we weren't. But even better, Jordan pointed out that this was his whole education in one nutshell. It allowed him to see how everything connected. And they came up with some really novel things. The PVC pipe you see is actually a robotic hand and arm. So that thing moves back and forth and can go up and down, and it can go over the top of the rock. And the orange part actually, inside of that orange part, spins. And those rubber bands are attached to it, such that the rubber bands will grab onto what's there and hold it and pick it up. And it's awesome. Lastly, we have, no, you go ahead. Lastly, we have the Astronomy Club and Galilean Society. They do really cool works. First of all, if you'd like to go look at the stars, please go check out Astronomy Club. They do awesome things that way. They go to the darkest spot in the Adirondacks to go look at the night sky. It is awe-inspiring. It's also cold, so depending on when you're going, make sure you bring something warm. But even better, so when I say that the school really promotes experiential learning, this is a great example of it. The students were excited. There was a transit of Venus, 7 years ago, where the Venus was going to go across the sun. And you get lots of data from that and be able to show various astronomical things. I don't want to get anything wrong. The school sent students to Hawaii because that was the best place to go look at it. And so you can see there's Ben Pons sitting by the telescope, pointing at the sun, taking pictures of how Venus is going across the sun on a ancient volcano in Hawaii. So now I'm not promising you're going to do that. Come here and go, hey, I want to go to Fuji. Can we do that around spring break time? I'd be all set. No, but we see that if there is a desire to do research and we can find a way to do it, we will make it happen. Lastly, as I said before, the astronomy education, we do a lot with children's groups and the North Country Planetarium. We will do children's groups in the planetarium. They have typically somewhere upwards of 60 to 70 shows a year in there. And some of it is for kids, some of it's for adults. They've even had wine tours coming in. And they said that was actually sort of fun because the people came in for the wine tours, they were a little tipsy. They were sitting there and they're giggling at every joke. And it made it a lot of fun. Anyhow, but it's, once again, I want to emphasize, run by students. So students give the shows, they run the equipment, they develop the shows. And Dr. Kisner helps develop all that. And she's awesome. So it's a great resource. I think that's it. Yep.
Thanks very much. At this time, I want to invite our webinar attendees to send us any questions you might have in the chat bar at the bottom of your Zoom screen. You should have a little chat button that you can freely type any question you might have, and our panelists will be able to answer them live for you. Let's see what we get.
So the first question I see is, what is the usual size of classes? So in physics, for freshman classes, they're a little bit bigger, order of 30-ish for freshman classes. And then by the time you get to the sophomore or junior year, you're down to high teens at most. So you're talking 16, 17, 18. In the robotics classes, those get even smaller. So especially in the upper classes, those experiential classes in terms of intermediate robotics and advanced robotics, those are capped at 12 because we want to give the students enough attention and that they feel like they get the support they need to make it through those classes.
Yeah, in computer science, most of our classes have a limit of about 30. And so there's about 30 students because most of the classes fill. In our applied learning experiential courses, usually it goes down to about 20 is the cap, and they mostly fill. The tech startup classes are kind of interesting in that they're set up to have teams of about 6 core members and then 6 kind of junior, people who are just kind of getting their feet wet types of things. But that's a kind of a smaller group for that one. The next question I see is, do I have any advice for applicants? And so I would say, if you're just interested in you're not applying yet, you're still in high school, I would say take as much math as you can and try to get as much background, and because math is a generally useful skill, and it's going to help you. The more you take in high school, the less you have to take here, and the sooner you can take your major courses. If you're already applied, if you don't have that background, you can catch up. Our majors are set up in a way that there is time to catch up, and it's not a huge deal. And once you get here, I would say that the big thing is just to take advantage of the opportunities that are provided here. So college, there's not a lot of you have to do these things at college. It's more of you can do these things at college. And so you can go to college and you can just sit in your room and go to your classes and not do anything else, but you'll be missing out on about 90% of what college has to offer. There's a lot of opportunities through the faculty and the departments, and also with your peers, with the other students, to get out and to do things and to take advantage of things. And so I would say just kind of push yourself, go out there and make the most of your time at college.
I agree wholeheartedly, especially with the part about getting out and doing things. We have. I'm very happy with how many outside opportunities there are for students here at City Plattsburgh. And for I come from Clarkson, where there's it's very much focused on a lot of that stuff, and I was surprised at how much of it is here. In terms of, let's say you are in your senior year and you've applied to come here, what else could you do? Well, one of the things is, you can go out and get like yourself an Arduino or a Raspberry Pi. They're not that expensive, and you just could play with them and see what you can do yourself before you come to class. Because then what happens is you might, oh, hey, I learned something new. You go to class and you already have an idea about how it works, but then oh, wait, I could twist my ideas of what I did, and that's sort of cool. Same thing with computer languages. There's a ton of stuff you can do online to help you with computer languages, just to get like your feet wet. We're not asking you to know how to program when you get here. We are not. We will show you that. But if you could learn, if you knew something about a language before you came, and then that would make it maybe a little bit easier for you when you take the class, and all of a sudden the syntax, how the words are, isn't as important. Why do you do these things? Oh, that makes a lot more sense. I'm self-taught, and that's one of my worst things ever, is why is this here? I can understand the syntax, but why is it here? That's what you'll get from the programs. That's the great thing. Do we get to work in labs in our first year? The answer is yes. So in physics, we go ahead and have physics lab that is built in. That is physics 1 and physics 2, which you will take in your freshman year, have lab and get hands-on with the material. But we also encourage even freshmen, if you want to do research with an advisor, you could do it. Matter of fact, you should, in my opinion. But you'll say, well, but I don't know anything. Correct. We're okay with that. There was once a ton of time that we didn't know anything. And so we know how to take you through the steps. You're not going to start out the first day and develop the theory about the Big Bang. Not going to happen. It's okay. But I can see, I can't. Dr. Adhikari can sit you in front of a computer and show you the simulation he's written and say, okay, here's some things that I want you to play with. Move these levers, see what happens. You could do that. And then as you see these different patterns of things that happen, you start discussing it. You develop a language with it with your professor, and you learn so much more because you start seeing, once again, going back to Jordan, you start seeing how class actually really applies to other things. And that connection is so important, because now it's not just a set of facts. We can Google facts. What we need people to do is put those facts together in something that's actually cohesive and useful. And so that's what we're doing that way. So, and then in robotics, there's always opportunities for labs. First year robotics, I'd almost say doing more with clubs, because that's where you're going to you can sort of apprentice in the physics club, and we go to robotics competitions, get in on that, and then apprentice there. And then in your second year, you can move into a more leadership position and do more things that way.
Yeah, on the computer science side, our introduction to programming class has a lab, and there's other opportunities. Different classes have experiential components to it. The next question I see is, can you get help from professors outside of the classroom? And definitely, all the faculty are available almost all the time. We try to set some limits, but people are very good about helping students out and being available. Generally, when we're eventually back on campus, you can just stop by their office, and usually people are there. You can just say hello and ask or chat or whatever. Nowadays, it's a little more formal in that you have to go to their Zoom link or whatever. But people generally are, they have set office hours when they're dedicated time to be available, and also they're very flexible about making other arrangements to meet and to talk with people. So they're happy to meet with you.
Yeah, I'll not only do I echo what Dr. Hart said, I also agree that the communities you can have here are pretty neat. When COVID is not around, the amount of students that hang out in the building, either to work with each other on projects or just to have the camaraderie of people going through a similar experience. It's amazing. So for us, we have a room right across the hall from my office, well, sort of down the hall, across the hall now, that is there for our majors. That's where they can go out and hang out and work on homework. And the great thing about it, it's across the hall from all of us physicists. So you have a problem, go knock on a door. And by the way, one of the greatest things about this place I love, you can go to other professors and ask them questions about other classes. I mean, now they're not going to tell you answers, but I've had some of my best people that I've still in contact with come by my office, knock on a door and say, Dr. Walters, I know you don't know me, but I did stuff for this intro class. Can you help me? They're not around. Yeah, sure, we could do that. And go right up on the board and do so. And so it's a lot of fun. It's great. Any other questions?
Yeah, I'll get the final call out for questions. It is 12:56. So if you have any last minute questions, go ahead and send them in the chat, or if either of our panelists have any last minute words of wisdom they'd like to share with our attendees.
So I just shared my email address in case people think of questions later on. You know, that oftentimes happen. You know, something pops in later. So.
And I did this.
Yep, that always happens to me. I always think of what I wanted to ask about an hour after. While we're waiting to see if anything else comes in, I always like to share a fun tidbit. I work at SUNY Plattsburgh. Obviously, I work in the admissions office, but I went here for my undergrad, and I was actually a physics major. So I took the very first robotics course before it was its own major, which is really cool to see how it's grown. But I can attest to a lot of what our panelists have said about the community and about the academic programs. It is a really great place to learn and to grow as a student. I was not a physics major to start. I was a biology major, yeah. And I had to take physics 1 and physics 2, and they didn't go very well at first, but they they converted me in the end. So that also attests to you don't have to be, you know, already amazing at physics or math. Math, you should probably be okay at math.
It does help.
But it's a really supportive environment.
No matter what you do, take advantage of your teachers, because that's really the good thing about this. That's why Danielle was a physics major, is eventually she did start taking advantage of the resources that were there. I mean, when she was in class, she would scowl at me for over an hour each morning, because that was just the way it was. It was 9 o'clock class. She didn't want to be there because it was 9 o'clock class. But over time, it worked out okay. So yeah, take advantage of. We are here for you. This is why we do what we do. We could be in industry. I was there for 10 years before coming back. I don't want to do that. I much more enjoy being a professor, helping people figure out where they want to be. And once again, start off someplace, and if it's not there, pivot, go someplace else. I had a robotics major that I was just advising yesterday, who just changed his major to music. He decided he was really more passionate about music than robotics. And he was sheepish about it. He's like, I don't know. I'm like, dude, if you're passionate about the music thing and that's what you got to do, cool, let's figure it out. And I spent 2 hours with him on Zoom to figure out how to be a music major and how to set up stuff, and hooked him up with some professors to do that. Really, just try stuff.
Well, I don't see any other questions coming through. So we will call this session to a close. For our attendees, there are a multitude of other things that you can go back to our virtual open house landing page and try out some other sessions, go on a virtual tour. And then if anyone, if you want to come back, we'll be here again at 1:15. And yeah, that's about it. Thank you.
Thank you.
Enjoy the rest of your day.
Enjoy.
And we'll be back here in a couple minutes.
Sounds good.